Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor, and today we're talking about one of my favorite things in all of circuits. It's voltage division. And the reason why it's one of my favorites is because it's going to save us a lot of time with simplifying circuits. So let me just show you what I'm talking about. Let's say I have the following circuit. It really can't get much easier than this. A battery connected to 3 resistors in series. If I wanted to find the voltage in any one of these resistors, I would have had to, in the past, combine all the resistors, R1 plus R2 plus R3, use Ohm's law, V equals I times R, where this resistance is the total, and then you'd find the current I, and then you'd use Ohm's law again through each individual resistor to find its voltage. The whole process takes a little over a minute if you know what you're doing. And if you don't know what you're doing, it will take you a couple minutes or until you give up and look at the answer key. But now with voltage division, we're going to have an easy formula to find each voltage in about 30 seconds. So first, I need to mention voltage division only works for resistors in series. If you have resistors in parallel, what are you doing? Remember, when I have resistors in parallel, they have the same voltage. So it's very easy to find the voltage when it's in parallel, it's just the same. But if you have resistors in series, here's how I can find the voltage across resistor 1, which I'll call V1. V1 is equal to the total voltage, in this case V bat, times the quantity, fraction bar. In the numerator is R1, the voltage that we want to find, and in the denominator is the total resistance, R1 plus R2 plus R3. And that's it. That's how we can easily find it for R1. And obviously, if you want to find voltage 2 or voltage 3, you would just sub out R1 with R2 or R3. Very simple. So now let's do a couple examples of this so we can see just how easy voltage division is. So here's our first circuit. My question is to find the voltage in each resistor. And I'd love to use voltage division here, but I can't because it only works for series. So what I'm going to do first is combine these two resistors, which are in parallel, which means I'm doing the parallel math, 1 over 2 plus 1 over 6 to the negative first power. If you didn't know that, that's how you add resistors in parallel. And that will get us an answer of 1.5 ohms. So now I'm going to redraw the circuit with the 8 ohm resistor still here, and now just one 1.5 ohm resistor right there. And now if I want the voltage in either the 8 ohm or the 1.5 ohm, it's very easy. I'm just going to say voltage of what I'm looking for, let's say the 8 first, is equal to the total voltage in the battery, 5, times the quantity in the numerator is 8, and in the denominator is 8 plus 1.5. So if I plug this in a calculator, I will get 4.21 volts, and that's the voltage in my 8 ohm resistor. And then if I want to find the voltage in the 1.5, it's the exact same thing, except I'm subbing out 8 in the numerator with 1.5. And plugging that in my calculator, I'm going to get 0.79 volts. Now hold on a second, that's the voltage in just the 1.5 ohm resistor. How can I find the voltage in both the 2 and the 6 ohm? Remember, they're both going to be the same thing, 0.79 volts. You do not split them up in half, you do not do anything like that. You just say it's the total voltage, 0.79. And that's it for this first one. Again, the strategy, you still combine resistors that are in parallel, but then once they're all in series, that's when we get to use voltage division. And now let's look at just one more circuit. So here's my circuit. Once again, the question is, find the voltage in each resistor. I encourage you to try this one on your own, pause the video, and when you're ready to see the solution, unpause. Okay, so once again, the first thing I'm going to do is I'm going to combine resistors in parallel. I have to combine these, and I also have to combine these. So the one on the left is going to be 1 over 2 plus 1 over 8 to the negative first power, which is going to be 1.6. And then the other one is 1/3 plus 1/6 to the negative first power, which gets us 2. And then as always, I'm going to redraw my circuit. Now I just have 2 resistors here up top. Left one's 1.6 ohms and the right one is 2 ohms. And now once again we can use voltage division to find the voltage in each resistor. So for the 1.6, voltage is the total 20 times the quantity, 1.6 over 1.6 plus 2, and that's going to give us 8.89 volts. So 8.89 volts right there. And then for the 2 ohm resistor, it's going to be V equals 20 times 2 over 1.6 plus 2. And that's going to be 11.11 volts. So I'll fill that in right there. And remember, once you get to this step and you look backwards at the previous circuit with the 2 in parallel, we know that parallel share the same voltage. So that's going to be 8.89 volts for the left 2 and 11.11 volts for the right 2. And we're done. That's it. We have all the voltages. And by the way, it will always add up to the total, which is 20 volts, so that's a good check. So that's all the problems I have for us today. Thank you all for watching. Hope you have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.